Throughout human history, the Levant, a small region connecting Africa to Eurasia, has punched far above its weight class. This narrow land bridge may be modest in size, but its influence is immense. The Levant is one of the world's oldest cradles of agriculture, trade, and urban life, and its spiritual resonance runs just as deep. This land is home to sacred places, like Mount Megiddo, linked to apocalyptic visions, and Jerusalem, revered by billions across multiple faiths. Here, history and holiness are inseparable. Myth, religion, and civilization all collided in this small strip of earth. Beyond shaping cultures and beliefs, the Levant shaped humanity itself. It sculpted human evolution and civilization, not just by hosting early dispersals, but by channeling them. The Levant's geography compelled ancient humans to interact and interbreed, imprinting their encounters on the genetic legacy of billions alive today. Neanderthals came from the West, and Homo sapiens out of Africa. But did they all meet in the Levant? Could you imagine the dramatic moments when these ancient ancestors crossed paths, unknowingly charting the future of humanity? This was no ordinary encounter. It redefined the very blueprint of our species, propelling the genetic and cultural trajectories that gave rise to us, modern humans. Fossil evidence from the southern Levant provides key insights into the dispersal and interactions of distinct human species over hundreds of thousands of years. What stories can we learn about our ancient ancestors? Can their traces help us unravel the mystery of who we are and where we come from? To answer these questions, we need to dig, literally, into the archaeological record of the Levant. Buried truths, digging through deep time. The Levant remains vital for understanding early human habitation and evolution, with many key findings emerging from sites in modern-day Israel. These aren't just isolated finds. They form a powerful timeline that stretches from the very edges of human prehistory to the dawn of civilization. At Ubaidiya, a vertebra dating back 1.5 million years, offers some of the earliest evidence of hominin presence outside Africa. 780,000 years ago, at Gesher Benot Yaakov, we find signs of controlled fire and elephant hunting, clues that early humans weren't just surviving here, but mastering their environment. At Chisholm Cave, some 400,000 years ago, unusual teeth with a mix of archaic and modern traits hint at a mysterious population that may have influenced the Homo sapiens lineage in unexpected ways. And at Mislia, a jawbone nearly 190,000 years old suggests that Homo sapiens left Africa much earlier than previously thought, reshaping our understanding of when and how our own species began to conquer the world. Each of these discoveries adds a puzzle piece to the long timeline of human presence in the region, revealing that the Levant wasn't just a waypoint, but a deeply inhabited homeland across millennia. Fast forward tens of thousands of years, and we witness a dramatic shift, from stone tools and hunting to something entirely new, domesticated life. Sites like Ainan, dated to around 12,000 to 10,000 BCE, and Jericho, dated to around 9,600 BCE, reveal how early humans began farming wheat and barley, domesticating animals like goats, sheep, and dogs, and forming some of the first permanent villages. These findings indicate that the Levant was a cradle of the agricultural revolution, which sparked a profound transformation that redefined human societies. These weren't just technical innovations. They reshaped how humans lived, organized their communities, and even worshipped. Together, these discoveries remind us that the Levant wasn't just a place ancient people passed through. It was where they innovated, adapted, and laid the foundations of the modern world. As Homo sapiens spread throughout the Levant, they might not have been alone. Fossils from Amud and Kabara caves confirm Neanderthal presence in the region around 60,000 years ago. This raises exciting possibilities. Did Homo sapiens and Neanderthals meet here? Were their interactions peaceful or violent? And most importantly, is it possible they even interbred in the Levant? Evidence says yes. At Manat Cave, A modern human skull dated to around 55,000 years ago offers a snapshot of this interaction. Although clearly Homo sapiens, it had some features seen in both Neanderthals and later European humans, possibly a sign of ancient interbreeding. This supports the idea that the two species coexisted, and maybe even intermingled, before modern humans spread deeper into Eurasia. If that contact occurred here, it offers a natural explanation for the relatively high levels of Neanderthal ancestry still present in many people today, genetic evidence of humanity's fateful encounter. Even you, watching now, might carry some of that same DNA. Now imagine a different scenario. What if Neanderthals had never lived in the Levant, only in Europe? In that case, Homo sapiens would have encountered them much later in their journey, only upon their arrival to Europe, and likely to a lesser extent. When Homo sapiens left Africa, some traveled through the Levant east into Asia, and others turned north into Europe. Only those who reached Europe would have met and interbred with Neanderthals, meaning Neanderthal DNA would be passed down mainly through European-descended populations. Even if some of these descendants with Neanderthal DNA had made their way east and mingled with Homo sapiens who never encountered Neanderthals, by the time that DNA reached places like East Asia or Australia, it would have been so diluted, it would barely register. If interbreeding had happened only in Europe, we'd expect to see a very different genetic legacy today. Neanderthal DNA would be mostly confined to Europeans, and even then, it would be unlikely to be as high as 2%. Populations farther away, Asia, Australia, the Americas, would carry far less, maybe none at all. But that's not what we see. We know that people from opposite ends of the globe, South America, East Asia, even Australia, carry nearly the same amount of Neanderthal DNA, about 2%. That simply shouldn't be possible, unless that mixing happened much earlier. There's only one place, one fateful crossroads of humanity, that could have occurred, right here in the Levant. It was here that Homo sapiens met and interbred with Neanderthals before continuing their journeys across the globe. This early mixing meant that almost all populations outside of Africa, whether in Jerusalem, Sydney, New York, or Beijing, inherited similar levels of Neanderthal DNA. No other region aligns with the archaeological, genetic, and geographical evidence as closely as the Levant, making it the most likely setting for these pivotal encounters. Alternative theories lack comparable support, rendering it highly improbable that such interactions took place elsewhere. But how do we unearth these ancient encounters, especially when bones and fossils alone can't tell the whole story? The Levant holds immense potential for uncovering the deepest roots of our species, but its harsh climate causes DNA to degrade quickly, posing a challenge for genetic research. In many cases, the bones are either too fragile or too decayed to yield any usable DNA at all. So what if the answers aren't in the bones at all, but hidden in the dirt beneath our feet? How can we detect ancient DNA, especially when it degrades so fast in the Levant? We have to develop and implement new technology. Enter sedimentary DNA, a revolutionary technique that allows scientists to recover microscopic genetic traces trapped in ancient soil. Often shorter than a tweet, these fragments hold volumes of evolutionary history. In the Levant, where ancient DNA degrades rapidly, bone-based discoveries are exceptionally rare, making this technology not just useful, but essential. Without it, crucial evidence of ancient human presence, including Neanderthals, might remain invisible. But the ground remembers. It tells us who walked here, who hunted here, who lived and mated here. Sedimentary DNA is transforming genetic archaeology into microscopic storytelling, revealing a hidden past once thought to be lost forever. It opens a powerful new window into our deep history, allowing researchers to trace ancient populations and ecosystems that once thrived in this crossroads of continents. But uncovering these secrets takes more than just curiosity. It requires innovation. To fully unlock the potential of sedimentary DNA and understand the intricate history of the Levant, researchers need cutting-edge methods and technology for DNA extraction and analysis. That's where scientists like Dr. Viviane Sloan of Tel Aviv University come in. Her work has helped refine methods for retrieving genetic material, even from extremely degraded samples, enabling researchers to retrieve genetic material even from poorly preserved remains and pushing the boundaries of what's possible in ancient DNA research. If we truly want to uncover the full story of us, who lived here, who met here, who mingled here, we need sedimentary DNA. Archaeology in the Levant, where the real dirt on human history gets unearthed.